Hey my friends, welcome back to the series on electrostatics, and this is the third video in the series. In past two videos we covered what is electric force and we did some questions on that. Today we are going to start the concept of electric field. So we will cover the concepts today. In an upcoming video in next 2 days I'm going to cover some questions and then that will be followed by Gauss law. So overall 3 videos on electric field. So this is the first one in the electric field. So let's first understand what we are going to study today. Electric field. So what is electric field and how is it related to gravitational field? So back in your previous years you've already studied that chota g is what I'm talking about, ye wala g, chota g, which you remember as 9.8 meters per second square. No, rethink what that means. That means anybody, let's say this pen cap, I drop it, it falls freely and it accelerates with 9.8 meters per second square. But take another look at it. What if I have 1 kilograms of object here? It experiences a force of 9.8 newtons. I'll repeat that. So 1 kilogram of object here experiences a force of 9.8 newtons. So this chota g can also be visualized as 9.8 newtons per kilogram, and then you can do the dimensional analysis. Meters per second squared is same as newtons per kilogram. So another way to look at this chota g is basically it's the gravitational field. All around me here there's a field, and that's gravitational field. 1 kilogram of object is going to be pulled down by 9.8 newtons. If there is 2 kilograms of object, it's going to be double of that, and that's where the concept of weight comes in. So weight, as you call it, a force of gravitation, is nothing but the mass times gravity. That is, if there are m kilograms, you are going to experience a force of that m multiplied by this gravitational field. Exactly same as the electric field. So electric field is, let's say all around me here there is an electric field. An electric field is going to be 1 kilograms की जगह 1 coulomb रखेंगे अब हम. So 1 coulomb of charge sitting here experiences how much of force? That is electric field. So let's summarize that, because that's going to be a little confusing for few students here. So let's say we are talking of gravitational field. I'm saying 1 kilogram अगर यहाँ पे रखा है, so how much is the force experienced by that? So the force experienced by 1 kilogram is 9.8 newtons. 2 kilogram है तो 2 multiply by that. Similarly, let's say there's an electric field here, and let's say electric field is something like 7 newtons per coulomb. What that means? 1 coulomb का यहाँ पे force रख दिया, charge रख दिया मैंने, तो that 1 coulomb of charge is going to experience a force of 7 newtons. 2 कूलम रख दिया तो 14 न्यूटन्स, -3 कूलम रख दिया यहाँ पे -3, तो -3 कूलम जो है ऑपोजिट डायरेक्शन में 21 न्यूटन्स का फोर्स. दैट इज ऑल. दिस इज ऑल अबाउट इलेक्ट्रिक फील्ड इन अ नटशेल. सो छोटा जी को कंपेयर करो इससे. ठीक है, अब आगे बढ़ते हैं, थोड़ा सा कूलम्स लॉ देखते हैं. जस्ट अ क्विक recap of Coulombs law. So what we studied in the previous videos, there are two charges here, Q1 and Q2. They have a mutual force, either attractive or repulsive, and that is given by k q1 q2 by r square. वो तो हमने पढ़ लिया था. अब सपोज यहाँ पे मैंने q चार्ज रखा है. सपोज forget the picture there. Let's say there's a charge q here, and at a distance of d, what will happen at a distance of d? At a distance of d, if I put 1 coulomb of charge at this point, it is going to experience a force of k times Q divided by D square, क्योंकि Q1 Q2 होता है, दूसरा Q तो 1 कूलम है, उसको 1 कूलम रख दिया, तो 1 coulomb of charge at this point is going to experience this much of force. So this is the electric field at this point because of this charge. तो दो बातें हमने अभी तक कवर करी हैं. First of all, let's say I know the electric field at a given position or a given point. It's a property of a point. Electric field is a property of a point. Like G is a property of this point. North pole पे जाएंगे तो दूसरा G होगा, है ना? G is a property of the point in space. Similarly, this point has electric field, let's say, of 7 newtons per coulomb. Who is causing it? I do not care. As if G is given to me, chota g is given to me, I will not ask you how much is the mass of the planet, how much is the radius of the planet. Agar nahi diya, then I will say, okay, provide me with the numbers and I'm going to calculate it myself. समझ गया? अगर नहीं दिया तो If you're not provided with the value of G, you will do that. If it is given, then it's given. Similarly, if electric field is given enough information, it is giving you the direction and the magnitude of the force experienced by 1 coulomb of positive charge. Suppose nahi diya. Situation, suppose nahi diya. So at this point, I'm asking you how much is the electric field. You say how much is the charge around it. So 5 coulombs of charge sitting at 2 meters. No worries. How much is the electric field here? Electric field here is K times this Q divided by the distance from the charge. इसका हो गया. Suppose यहाँ दो charge होते हैं. Suppose यहाँ पे था 7 coulombs का at a distance of 3 meters. No worries. Then you have another electric field here, which is K times law of superposition, my friend. The same thing that you studied in the previous videos, 3 का square. Supposing negative था यहाँ पे, negative 6 coulombs at a distance of 4 meters, let's say, तो negative की तरफ pull हो जाएगा वो. तो electric field is going to be dependent on positive के negative. अगर positive से है, positive के current will be going the other way, away from positive charge. Because again, if you think about it, if you have a positive charge, है ना, it's sitting here, positive Q. If you want to find the electric field here, मतलब you are going to place 1 coulomb of positive charge, it's going to be repelled by that. So electric field is going away from the positive charge. अगर negative charge होता, and then you put positive 1 coulomb here, so then by definition, you have to put 1 coulomb of positive charge, so it is going to be attracted. So electric field is going towards the negative charge. यहाँ तक थोड़ा सा अगर clear है तो we can do this simulation here. So look at this. This is a point. There's some space here. There is no electric field right now because there is no charge. If I put a positive charge here, look at what happens. There's an electric field going away from that. Now, in other words, there is an electric field going away from the positive charge. Another thing to note here is the farther you are from that, the weaker the electric field. Because remember kq by d square. Look at the farther points. They have a weaker electric field. देखो ये दूर के points जो हैं left side के, they have weak electric field. अब यहाँ negative रख दिया मैंने. Negative रख दिया यहाँ पे तो electric field is going towards that. अब मैंने क्या दोनों रख दिए. Look at this. Look at the interaction. Look at interaction. The electric field is coming out of the positive charge going into the negative charge. So after that simulation, let's see some pictures here. Field lines अगर बनानी है तो what was the electric field? Electric field is a property in space and that tells you how much will be the force experienced by 1 coulomb of charge at that point. तो इस point पे अगर मैंने निकाला electric field, the direction is this way. इस field पे निकाला direction is this way because there is a positive charge kept over here. So you can find the electric field at all the neighborhood points. यहाँ पे पता किया तो it's going to be this way. यहाँ पे पता किया it's going to be this way. So you can find everywhere. And then you can plot these lines. So these lines actually give you a visual kind of okay, what is the electric field in this region. तो अगर positive charge है, you will have electric field lines going out of it. क्योंकि यहाँ पे अगर positive 1 coulomb charge is sitting here, then you have force going away from that. Negative charge will have a field going into that. We already saw that because by definition, एक कूलम के पॉजिटिव चार्ज को कितना फोर्स है? पॉजिटिव चार्ज का फोर्स will be towards the negative charge, and that is why the field lines will go into the negative charge. They'll come out of the positive charge. Anything that is not clear in this video, you're supposed to write in the comment box down here. I'm going to either create a tiny little video for you, or I'm going to try to cover that concept जो नहीं समझ में आ रहा in detail in typing the answers over there. So feel free to ask any doubts here. तो अब ये दूसरा आ गया situation which we already saw, एक positive एक negative ले लिया, तो you can see how the field lines are going out of the positive charge and they go into the negative charge. So field lines will emerge out of the positive charge, they will end at the negative charge. And this by the way, my friends, you might have already studied in chemistry also, this is a dipole. So what is a dipole? Dipole is two charges, equal and opposite usually. So equal and opposite charges separated by some distance. What distance is usually very tiny. It can be big also, tiny also, but it cannot be zero. क्योंकि अगर zero होगा एक one on top of other, let's say together, it's a neutral body. Because as such, dipole is going to be neutral body. But because they're separated, it's going to create a different kind of electric field around it. तो ये dipole हो गया. अब now let's say there are two positive charges. है ना? तो ये देखो how the field lines are repelling here, and this you've already studied in your junior grades for magnetism, that field lines never cross, and the more the field lines are, the stronger the field there is. I mean, those properties are still same what you studied in magnetism, and we are going to study magnetism in few weeks from now anyways. So electric field lines, let's summarize. Electric field lines give you by, like, what is the direction of force experienced by positive charge over there. Now, the closer these are, the stronger the field is. So you can see in this zone here, this is a strong field, this is a weak field, right? So that's the whole point. Now, field lines will never cross each other, because क्रॉस नहीं कैसे करेंगे, दो फील्ड हैं तो वो सुपर पोजिशन से एक बन जाएगा, चार फील्ड हैं वो सारे मिक्स होके वेक्टर एडिशन हो जाएगा, दे नो वेक्टर अलजेब्रा, field lines no vector algebra, they will calculate the resultant, and that is the resultant electric field at that position. एक position पे one electric field, not two. Now, this is where something interesting starts. Inside a conductor, what happens inside a conductor? And most of the books are not giving you the reason for this. Let's go into a little depth what happens inside of it. Let's say I have some conductor, a shell, not shell, yeah, the solid, solid sphere area. And if I give it some charge, how do you give charge? You've already studied. Either you take away electrons if you want to give it a positive charge, or if you want to give a negative charge, you supply more electrons. अब मैंने मोर इलेक्ट्रॉन्स दे दिया, इसको स्प्रिंकल कर दिया एक सॉल्ट की तरह, ठीक है, ओवर सिंप्लीफिकेशन, बट लेट्स से वी गिव इट सम एक्स्ट्रा इलेक्ट्रॉन्स. whatever is the extra charge in there, 5 कूलम चार्ज दिया तो वो 5 कूलम चार्ज पूरा स्प्रेड आउट सरफेस पे हो जाएगा. वी विल सी द रीजन व्हाई. अगेन, सो अगर तुमने जो भी चार्ज दिया, whatever charge, positive, negative, whatever charge you give it, that charge is going to be immediately spread out at the surface. अंदर कोई चार्ज नहीं रहेगा. No charge inside of a conductor. Only conductor की बात कर रहे हैं हम, इंसुलेटर की नहीं बात कर रहे. कंडक्टर, कॉपर, एल्यूमिनियम, आयरन, something conducting body. So you will always have extra charge. चार्ज का मतलब ये नहीं कि सारे इलेक्ट्रॉन्स प्रोटॉन्स बाहर आ गए. The charge, the extra charge you gave it, है ना, that is going to be at the surface of a conductor. We will see the reason for that. Okay, पहले reason ही देख लेते हैं. Let's say this is some conductor and I give it some charge, and a positive charge दे दिया. So let's say I give it some positive charge. What would happen now? What would happen is, let's say there are field lines that will be created inside of it, right? Because charge means field, we have already seen that. अब now conductors have free electrons, है ना. कंडक्टर, इसीलिए मैंने कंडक्टर बोला, because conductors have free electrons. फ्री इलेक्ट्रॉन्स मीन्स नेगेटिव चार्ज, है ना. तो नेगेटिव चार्ज इलेक्ट्रॉन्स जो हैं, दे आर गोइंग टू बी एक्सपीरियंसिंग ए फोर्स उल्टा in this direction. So again, one more time, if you did not follow that, so let's say there was an electric field of 7 newtons per coulomb here. If I put positive charge, it will experience a force in this direction. A negative charge, remember I had put negative 3 coulombs here, it experiences a force ulta to that. Now, these electrons being negatively charged, they will experience a force backwards. Force means acceleration. Acceleration means it will have some velocity now, and they will start rearranging. So यहाँ पे जब मैं rearrange हो गया, तो eventually there will be no electric field inside of a conductor. Electric field zero है क्योंकि there is no charge inside. We will study more on electrostatic shielding now. So let's say there is an electric field. So that is property number one, that all the extra charge you give is going to be spread out at the surface only. Secondly, there is no electric field inside of a conductor. क्यों? Let's see. कोई magic नहीं हो रहा. So let's say there is an electric field here. है ना, क्यों है? Because there are some positive charges here, or there are some negative charges here, but I'm least interested in the source of them. If I'm giving you the electric field, that information, again I'm repeating, is more than enough. I'm not interested in telling you, you're not interested in knowing okay, who is causing it. Maybe these negative charges, or maybe these positive, or a combination of them. But let's say there is an electric field here. अब मैंने लाके कोई एल्यूमिनियम पीस, कॉपर पीस, some kind of metal यहाँ पे रख दिया. मेटल रखने से क्या हुआ? मेटल और कंडक्टर हैज फ्री चार्जेस, फ्री इलेक्ट्रॉन्स, दे कैन मूव अराउंड. There is a field in this direction, so what would happen is electrons will start piling up here. And this is, by the way, oversimplification, but that works. When electrons start piling up on this side because they have a force backwards, that means this side keeps becoming negatively charged. But the right side has lost some charges, which is negative charge. So right side becomes positive. Remember this metal conductor is still a neutral body, but the charges have rearranged themselves कि यहाँ positive या negative. बट यहाँ पॉजिटिव यहाँ नेगेटिव से क्या हो रहा है, यहाँ पॉजिटिव यहाँ नेगेटिव से एक और इलेक्ट्रिक फील्ड बन गया यहाँ पे, because electric field due to these charges, the blue electric field is because of some external source, we are not even interested in that है, बस ये पता है. But because of these rearrangement of charges inside the conductor, there is an electric field that has been developed now. This electric field, अब उससे क्या होगा, कोई भी एक point ले लिया मैंने random यहाँ पे, it has two electric fields now. One electric field because of the external source and one new electric field which has been developed just now. So you can see one is going right, one is going left, law of superposition, vector algebra, one is going to cross out the other. पूरा नहीं, पूरा wipe out नहीं है, because blue is still bigger than green, but it has been reduced. The electric field has reduced now. But reduce matlab kya? It is still there. So then more electrons say, yes, we will join the party here, and they come up here. And that means more positives here. But as more electrons are moving here, more polarization is happening here, the green field gets stronger and stronger because more charges, more the field. So yes, stronger there are. Blue is still same, green keeps getting bigger and bigger to a point when green and blue are exactly equal and opposite, no more motion of the electrons. अब net result क्या हुआ? You take any point random here, it has two electric fields, one going right, one going left, equal and opposite. So there are fields in here, but they cancel out each other. It's like saying there's a box here, I'm applying 10 newtons here, you apply 10 newtons here, I would say the net force is zero. There are forces, but there is a net force of zero here. That's exactly what is happening here. So as soon as you put a conductor inside of a field, अंदर सारा field खत्म हो गया. Everything is gone. There is no field that can exist inside of a metal or inside of a conductor. And that is a very useful property actually, and we will see how that works. So let's say there are some positives here, some negatives here, there were field lines, but you can see what happens here. The electric field lines are ending here because all that, remember that electrons have come up to the left hand side, the electric field is ending here and then they re-emerge, but inside koi electric field nahi hai. Similarly, you can see here cavity here. Now I'll talk about this point, just hold on, I'll talk that point also, but overall look at how electrostatic shielding is working here, and then few more cases. You should try these cases yourself. You put a charge inside here, what would happen? So this is basically a big sphere, and then there's a cavity inside. Inside cavity I have put some charge. So you can see how the field lines were coming out here, but all this metal, this was a metal, it has rearranged all these negatives and positives so that the field lines end here and the field lines come out here. So inside this metal there is no electric field. ठीक है, यहाँ तक हो गया. Now there was another point that was to be discussed here, this perpendicular. Perpendicular का क्या मतलब? So number one property we saw is all the extra charge you give it to a metal, it redistributes itself so that everything is at the surface. There's no extra charge inside. Secondly, there is no field inside. Thirdly, the field lines that come out here, these are going to be 90 degrees. ऐसा नहीं होगा कि कोई field line is going this way. It's not possible. Why not possible? Let's understand. Let's understand that. So let's say there is some field line, and by argument I say कि नहीं ऐसा थोड़ी होता है. There is some field line that is going to be not 90 degrees. But if there is a field line that is not 90 degrees, I can always resolve that into E cos theta and E sin theta. E sin theta तो चलेगा, है ना, that's fine. But E cos theta means there is a field tangential to the surface of metal here. If there's a field tangential to the surface of metal here, there are electrons which can move opposite to that, and they will redistribute and make sure that this is gone. That means this is no longer inclined, it is going to be perpendicular. एक बार और समझा देता हूँ कि these are the things you don't get to read in the book. So let's say there was a metal here, and I say, okay, nahi yaar, electric field is not 90 degrees. Electric field is at some angle which is not 90 degrees. It is at theta. So if it is at theta, that means there is a component of electric field which is E cos theta. But if there is a E cos theta, some electric field here on the surface of the metal, if there is a field going this way, let's say this way, so then electrons will say, okay, we are getting a push backwards, and they're going to push back. So they will go the other side and make sure that all this rearrangement, there is no electric field, because electric field होगा तो वो charges move करते रहेंगे. So eventually this will be gone, and this is no longer inclined, and the field will always be perpendicular to the metal surface. So electrostatic shielding की मैं बात करता हूँ, but before that, these are a few points that we covered just now. So extra charge moves to the surface. कोई भी एक्स्ट्रा चार्ज तुम दे दोगे उसको मेटल को, 5 कूलम दिया तो 5 कूलम सरफेस पे, अंदर कुछ नहीं है. नो फील्ड कैन एग्जिस्ट इनसाइड ऑफ इट. And we are going to do some questions, and when we study Gauss theorem in 2 videos from now, you will understand more about this further, why there is no field and all that. So field is always perpendicular to the surface, ये भी हमने पढ़ लिया. Now electrostatic shielding का सबसे बड़ा example, let's say there is lightning. It is always advisable कि you don't stand under the tree, you actually sit inside the car. क्यों? क्योंकि car is made of metal. है ना? So this metal is actually providing you kind of a metal cage. It is shielding you. No field can come inside. Strike करेगी lightning, but it cannot enter inside. And this is one of the. Another is, I don't know if you can see those speakers there. So when you have speakers, many of the speakers actually have a layer of metal around it. That is again to prevent any electric disturbance going into the speakers, and also TV, so that the signals are not distorted. So that's another example of it. Now, what is dipole? And this is the last topic we are going to cover today, and we'll do 2-3 questions on this. So this video, I think, will last for another 7 or 8 minutes, and we are going to do questions in an upcoming video. We'll do 3 questions today. Dipole kya hai? We have already studied in your chemistry classes maybe. So there is a plus Q here, let's say, and then there is a minus Q here. And let me make it a little farther away. So some charge equal and opposite separated by distance. Kitna distance? Usually the distance is taken as 2a. क्यों लेते हैं? We'll see that, because if I take it as a, I'll have to deal with a by 2. 2a लूंगा तो a से काम चलेगा. In order to avoid fraction, we are taking the distance 2a. तुम a भी ले सकते हो, but advisable to do that. Now let's say there is, and this is an imaginary line, obviously the axis of this, right? Let's say I want to find the electric field here. Electric field here is because of 2 charges, positive Q and negative Q. And let's say the distance here from here to the center of this, usually that's the convention here, because उससे easy हो जाएगा ना. कहाँ से distance लोगे? Center से ले लेंगे, क्योंकि यहाँ से लिया तो थोड़ा सा है ना. So let's say the distance is something, I don't know, d ले लिया. I'm interested in finding the electric field at a distance of d from the center of this dipole. सबसे पहले तुमने केमिस्ट्री में भी पढ़ा होगा, बट आई कवर अगेन. सो डायपोल मोमेंट इज यूजुअली द चार्ज, है ना. ओवरऑल चार्ज तो 0 है, बट चार्ज ऑन व्हाटएवर दैट इज मल्टीप्लाइड बाय द डिस्टेंस बिटवीन देम. सो दैट इज द डायपोल मोमेंट, एंड इट्स अ वेक्टर क्वांटिटी. That's a side note there, because we are going to use that in the derivation here. So इधर देखो, अगर इधर because of positive there is an electric field going this way. कितना electric field? K times Q divided by distance square. अब distance कितना है यार? Distance अगर तुम देखो तो ये पूरा D था, उसमें से ये A minus करना पड़ेगा, है ना, because that's extra. So the distance is D minus A. So let me write D minus A का whole square. That is the electric field going left. Very ugly line मैंने बना दी है, but that's exactly going away from this. Let me redraw that with a bold maybe. ये better है ना? That's because of positive charge. अब because of negative charge there is a field here, and they're not equal and opposite. So ये कम होगा क्योंकि distance from negative charge is more. So how much is this field? This field is KQ divided by distance की not d plus a हो गया. See, अगर मैंने distance a लिया होता तो a by 2 लिखना पड़ता यहाँ पे, इसीलिए 2a लिया था. अब फील्ड कितना हो गया? ये वाला माइनस ये वाला, है ना. तो ये माइनस ये ले लिया, तो कितना हो गया? K Q बाय डी प्लस ए का होल स्क्वायर। बेसिकली वहां से ले लो तो इजी हो जाएगा, क्योंकि मैग्नीट्यूड चाहिए मुझे, तो वो वाला ले लेता हूं मैं, है ना। तो रेड वाला बड़ा है तो रेड वाला बड़ा कर दिया। ओवरऑल आई नो द डायरेक्शन इज गोइंग दिस वे, दैट्स ऑल आई मीन टू से। तो a square minus, so again I'm going to repeat why I have written this one here, because this is bigger and this is smaller, है ना, इसलिए किया है मैंने। एंड ओवरऑल आई नो बिगर इज गोइंग टू विन, सो ओवरऑल द डायरेक्शन ऑफ दिस इलेक्ट्रिक फील्ड इज गोइंग अवे, तो वो तो मेरे को पता है। अब ये तो बेसिक अलजेब्रा, इसमें मैं क्या सिखाऊंगा। सो ये के क्यू आ जाएगा, ये 2 da 4 da बन जाएगा, डिवाइडेड बाय डी स्क्वायर माइनस ए स्क्वायर का होल स्क्वायर। ये इलेक्ट्रिक फील्ड हो गया। सिंपल सा 2 लाइन का डेरिवेशन है, इसमें कुछ है नहीं। तो but I would advise you do it yourself, try to analyze this और क्या कैसे, है ना। but let's say usually as I said dipole का जो distance है इन दोनों charges का, that's very tiny, so this 2a is very small, very small, and we are talking about this dipole and distance somewhere there. So we usually talk about when d is much greater than a, बहुत ज्यादा, क्योंकि obviously dipole के distances are so tiny, distance between those charges. So in that case, I can actually ignore this part, a square. है ना, this you might have already done in your mathematics class, so you can ignore that. तो नीचे बचेगा d to the power 4, ऊपर एक d है, वो कट जाएगा. These calculations you should do yourself. So in that case, the electric field comes out to be 2q 4, है ना, नहीं 2q कहाँ से 4, है ना, 4q k और क्या बच रहा a डिवाइडेड बाय d to the power cubed. और ये अगर देखें हम यहाँ पे, ये जो P था Q टाइम्स 2a था, तो यहाँ से एक 2 बोरो कर लिया, तो ये क्या बन गया K टाइम्स P, है ना, और एक 2 बच गया डिवाइडेड बाय D क्यूब। ये मेरा इलेक्ट्रिक फील्ड आ गया एट एन एक्सिस, एट सम एक्सिस ओवर हियर। Now there's a little homework I would ask you to do yourself. I'll just give you some pointers there, क्योंकि सारा अगर मैं करा दूंगा तो वो तो फिर बुक में भी करा हुआ है। Obviously मैं थोड़ा different कराऊंगा, I'm sure, but still, unless you do it yourself, you're not going to learn. So again, the same scenario here. You have a distance of 2a here. Now इधर हमने distance d लिया था, right, at the axis. Now instead of that, I'm interested in finding the electric field here at this point, which is at a distance of d from the center here. I'll give you a quick clue on what you do here. Is this because of this positive q? Let's draw the line here, है ना, ये because of this positive q you have some electric field here, कितना k q by distance square। अब distance square कितना है यार, वो तो d square plus a square है। पाइथागोरस थ्योरम लगाइए माय फ्रेंड्स, जस्ट पाइथागोरस थ्योरम, है ना, ये डिस्टेंस ये था, इसका स्क्वायर कर दिया। अब नाउ इफ यू लुक एट द नेगेटिव चार्ज, द इलेक्ट्रिक फील्ड गोज टुवर्ड्स द नेगेटिव चार्ज, बट दैट इटसेल्फ इज एग्जैक्टली इक्वल दिस टाइम। द मैग्नीट्यूड इज सेम, मैग्नीट्यूड डिफरेंट नहीं है, क्योंकि डिस्टेंसेस आर सेम, द चार्जेस आर सेम, दिस इज एग्जैक्टली सेम। अब क्या करोगे तुम इसको, या तो देयर आर टू वेज टू डू दैट। वन इज कि भाई ये 120 डिग्रीज था, आई कैन डील विद दैट, बट अ बेटर वे इज which I prefer, and you can use this method if you want, but I would prefer कि ये जो E है उसको मैंने ये नहीं 120 नहीं था, इक्विलेटरल नहीं है, थीटा था ये, तो यू कैन फिगर आउट कि थीटा था तो कितना था, है ना। आई एम रियली सॉरी फॉर दैट इंफॉर्मेशन। सो लेट्स नॉट टेक इक्विलेटरल ट्रायंगल हियर, लेट्स से सम जनरल एंगल देयर थीटा, क्योंकि वो स्पेशल हो गया ना, स्पेशल केस बाद में रख लेंगे। थीटा है तो ये भी थीटा हो गया, है ना, दिस इज थीटा, सो दिस कैन बी E cos थीटा, ऊपर वाले की बात कर रहा हूं मैं, इस वाले की, है ना, E cos थीटा और E sin थीटा। अब नीचे वाले का देखो तो वो भी E cos थीटा आएगा, E sin थीटा, E sin थीटा, E sin थीटा कट हो गए तो 2E cos थीटा आ गया। अब cos थीटा क्या है, cos थीटा इज बेस डिवाइडेड बाय दिस, सो यू कैन प्लग दैट इन। सो मैं क्विकली कर ही देता हूं, बचा क्या है इसमें। तो ओवरऑल इलेक्ट्रिक फील्ड मेरा आ गया 2E, E कितना है, ये अपनी फोटो हटा दूं यहां से, है ना, 2E which is 2 times k cube by d square plus a square into cos theta। cos theta कितना है, cos theta is base divided by hypotenuse, तो ये to the power 3/2 आ गया, 3/2 आ गया, तो you can obviously do that, again a को इग्नोर कर दिया तो d cubed आ गया, और overall same thing आ गया, exactly same thing, except that this is going to be half of that। You can take the special case there and do that। तो प्रैक्टिस कर लेते हैं थोड़ी सी. This is one of the questions that I gave in the past video for homework. This video number 2, this is video number 3. So इसमें कर लेते हैं. तो पहला क्या था केस, 3 माइक्रोकूलम है and then you have प्लस 8 माइक्रोकूलम, है ना. इसको इसके बीच में कोई डिस्टेंस था, आई डोंट इवन केयर, कोई डिस्टेंस था d. तो फोर्स कितना था, फोर्स वाज F इज इक्वल टू K Q1 Q2, तो 24 बन गया वो, है ना. 24 डिवाइडेड बाय डिस्टेंस स्क्वायर. अब माइक्रो का आई डोंट इवन केयर बिकॉज सी दीज थिंग्स आर गोइंग टू क्रॉस आउट, सो आई डोंट रियली केयर. अब main point here is when you give -5 coulombs to this microcoulombs, obviously this gives you a total of -2 microcoulombs, और इसको -5 microcoulomb दिया तो this becomes 3 microcoulombs. तो ओवरऑल फोर्स कितना आ गया, फोर्स आ गया, फोर्स इज इक्वल टू K टाइम्स -6 आ गया, -6 divided by d square. Now you can clearly see the magnitude of this red force is 1/4, but then with a negative sign. So 1/4 कितना, पहले 40 था, उसका 1/4 हो गया 10 newtons with a negative sign there. ठीक है. So that's all you had to do in this. So let's do the questions on electric field. There is an electric field of so much that points to the west at a certain spot. तो spot बना लिया. And pause the video, please. Pause the video. Try the question yourself. It's a very easy question to boost your confidence. अब try कर लिया, then you come back. Newtons per coulomb of here. What is the magnitude and direction of the force if 7 microcoulombs of positive charge is kept here? So obviously force is equal to charge multiplied by electric field, because remember electric field is जितना भी होगा, that is basically for 1 coulomb, q coulombs है तो q times of that force, है ना. अगर नहीं समझ में आ रहा तो you can plug in the units also. 7 का ये भी लिख दो, 7 times 10 to the power -6 coulombs आ गया, है ना, multiplied by electric field is 1 2 3 4 5 newtons per coulomb. So see how coulombs cross out and the net answer is in newtons. तो 7 times 2 is 14 और एक माइनस वो कर दिया तो 1.4 newtons west, because it's in the same direction as positive charge. अगर negative charge होता तो east हो जाता, या तो east होगा या west होगा, है ना. It's not कोई oblique direction आ जाएगा. Either the charge will be positive or charge will be negative. देखो अब इसको please again pause the video, think carefully and then return back. Very easy. So largest क्या है? This is the largest, isn't it? क्योंकि field lines are so close and this is the weakest. तो क्या होना चाहिए? B C A, right? B C A, पहला वाला ऑप्शन. Look, we are doing very basic questions today. Next video में difficult questions आएंगे, बहुत difficult भी आएंगे, जिसमें calculus भी लगेगा. One of the questions will be with the distribution of charge on a non-conductor where the charge is varying with the distance. We'll do different difficult questions also next time. अभी simple case करें just to understand electric field के. The drawing shows a positive and a negative point charge. The negative charge has a greater magnitude. Where on the line? है ना. पॉज करो, इसको पॉज करो. चलो अब इसको देख लिया तो ट्राई करते हैं. इसको 3 जोन में, यूजुअली दीज काइंड ऑफ सिनेरियोज यू डिवाइड इनटू 3 जोन्स. जोन नंबर 1, जोन नंबर 2, मतलब जोन नंबर 1 ये है, जोन नंबर 2 ये है, जोन नंबर 3 ये है. नाउ लेट्स ट्राई जोन नंबर 2. अब जोन नंबर 2 में take any point randomly. Electric field because of positive charge will be in this direction. Electric field because of negative will also be in the same direction. तो how can they be zero? They cannot cancel out. तो ये rule out हो गया, यहाँ पे हो ही नहीं सकता, possible ही नहीं. अब यहाँ देखें अगर हम, because पहले अब तो अपनी फोटो हटाओ यहाँ से, हाँ यहाँ आ गया. So because of the positive charge, there is a field because of positive charge, and then there is a field because of negative charge. But negative charge is close, positive charge will always be less, है ना. ये always is going to be more, and this is always going to be less because you're far away from positive. तो cancel नहीं कर सकते, they can never be equal and opposite. तो ये भी rule out हो गया. अब थर्ड वाला केस बचा, obviously वही आंसर होगा, but let's see why. Let's say you take a point here, because of positive charge you will have a field here, because of negative charge you will have a field here. Negative charge is bigger, है ना. They're telling you negative has greater magnitude. तो field का क्या फॉर्मूला होता है? K cube by d square. Now negative का ये more है, but distance भी तो more है ना, it's farther away, so it can be equal to the positive charge. There will be one point here somewhere where you can figure out, so it will be to the left of the positive charge. This is where you can find a point. हाँ, अब ये तुम्हारा होमवर्क है. दिस इज द लास्ट क्वेश्चन फॉर टुडे. दिस इज योर होमवर्क. 2 पॉइंट चार्जेस है ना, ये पड़े हुए हैं. द लोकेशन, सो मैं एक बार ड्रॉ कर देता हूँ, so that just to give you at least a start there. So let's say this is location x is equal to 0 and there is a location x is equal to L. यहाँ plus 8q है, minus 2q है, right? Now you have to find a location on this axis. यहाँ नहीं पता करना है, ऐसा नहीं कि I have to find it here, 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 on the red line itself, where the field is 0. अब field is 0 कैसे करोगे? यहाँ पे zone number 2 में decide करोगे, तो this and this they never cross out, नहीं हो पाएगा, पॉसिबल नहीं. जोन नंबर 1 में करोगे, बिकॉज ऑफ पॉजिटिव दिस इज हियर, बिकॉज ऑफ पॉजिटिव, बिकॉज ऑफ नेगेटिव इट इज हियर, बट दिस नेगेटिव इज गोइंग टू बी लेस ऑलवेज, क्योंकि फर्स्ट ऑफ ऑल द चार्ज इज टाइनी कंपेयर टू दिस एंड द डिस्टेंस आल्सो ह्यूज हो गया, तो इट इज नॉट इवन पॉसिबल हियर. The only possibility is here, because of positive it is here, negative here, but negative can be balancing out positive. So what you do here is you take a distance of x here and then you find the field because of this kq by k2q by x square, और उसमें distance l plus x हो जाएगा, and then you say these are equal and opposite and you will be able to figure this out. Take it as a challenge homework, very easy. Next time we are going to do questions, but there is Gauss law remaining in electric field, so there are situations where you don't have these point charges, but you have a distribution of charge and you have to find the field because of that. But instead of doing the calculus, you can use 2 or 3 lines of work here using the great Gauss law. Gauss law is going to make a question that would need 20 lines of solution into 2 or 3 lines. So वो upcoming video में नहीं, upcoming video we're going to do some questions and this homework question also we'll cover in that, but then we'll do Gauss law later. So we always end the class by something motivating. So only you is your limit. So basically what that means in simple words is you define your limit. अगर तुम बोलते हो मैं नहीं कर सकता, तुमने अपनी लिमिट वैसे ही कम कर दी, तुम बोलो मैं तो कर सकता हूँ यार, you decide your limit, nobody else. There is no physical challenge that should stop you. There should be no financial, emotional, mental, no challenge there. The only challenge should be decided by you कि ये तो यार piece of cake है, मैं कर डालूंगा उसको. So with that said, I'll see you again in 2 days. I'm going to upload another video for questions. So thank you. Bye bye.